In today's lesson, we're going to be learning about slope. The term slope refers to the steepness of a line. On a graph, you always analyze a line by reading from left to right. A line that is diagonal on a graph either has a positive slope or a negative slope. And so in example number 1, they would like us to determine what kind of slope does each line below have. Okay, so again, just like you read a sentence in a book, you analyze a graph by reading from left to right. What is happening to this line as we move from left to right? Well, that line is decreasing as we move from left to right. Therefore, this is a picture of a line that has a negative slope. When the line is decreasing as you move from left to right, we say it has a negative slope. On this second graph, as we move from left to right, notice that this line is increasing. Therefore, this is an example of a line that has a positive slope. When the line increases from left to right, we say that it has a positive slope. So we've actually done some graphs earlier in the year when we talked about proportional and non-proportional relationships. Recall that a graph shows a proportional relationship if there are two things. The first thing that we need is a straight line. Okay, if your graph isn't a straight line, then we know for sure that it's not a proportional relationship. Okay, but besides having a straight line, that straight line also passes through the origin. Okay, the line has to pass through the origin in order for the relationship to be proportional. Looking at the two graphs that we had up above, notice that both of them are definitely straight lines, and I can see that each line is passing through the origin. So both of these show a proportional relationship. If there's a proportional relationship, remember then that there is a constant of proportionality, which we use the variable k to represent. The constant of proportionality is always found at the same point of 1 comma k. Find where 1 is on the x-axis, go up until you hit the line, and then you'll be able to find the corresponding k value. The way that you calculate the constant of proportionality, remember that k equals y divided by x. The equation of a proportional relationship is always in the same form of y equals k times x. Every proportional equation will be in that form. So in practice question number 2, it says to state the constant of proportionality and the equation of each graph shown above. So for graph number 1, let's first calculate k, the constant of proportionality. Remember, we do that by doing y divided by x. And all we're going to do is try to find a point that the line passes through. Besides the origin, that is. If we use the origin, that's not going to help us find the constant of proportionality. But any other point that it passes through will work. Okay, so I notice that it passes through this point right here. And if I follow along with the dimensions, they're calculating every line is equal to 2. So this is the point 2 comma negative 2, 4, 6, 8. This is the point 2 comma negative 8. So since the line passes through the point 2 comma negative 8, I can substitute these values in to calculate k. The y value is negative 8 and the x value is 2. So k equals negative 8 divided by 2, which equals negative 4 over 1, or just negative 4. The value of k is negative 4. And now for the equation, all I'm going to do is substitute that value into this equation, y equals k times x. The equation of the line above is y equals negative 4x. All right. Our constant of proportionality was negative. And realize what we said before, the slope of that line was negative. All right. How about for the second graph? Same idea. We're going to find a point that this line goes through. They've actually plotted 3 of them for us. Let's use this first point right here. That is 5 in the x direction, 2, 4, 6 in the y direction, 5, comma 6 that line passes through. So just like we did before, k equals y divided by x, and we said it passes through the point 5 comma 6, which means that the y value is 6, the x value is 5, and this fraction actually doesn't simplify. So I'm going to leave my k value as 6/5, which means that if I substitute into this equation, then the equation of the line, is y equals 6/5 x. In our last example, the constant of proportionality for each graph represented the slope of the line, okay? The constant of proportionality will always represent the slope of a proportional relationship. On a graph, the slope shows the rate of change and is represented as the ratio of the vertical change to the horizontal change, which we call the rise to the run, okay? So slope is equal to rise over run. The rise over here is always vertically, and the run over here is always horizontally. Slope equals rise over run. And the way that you calculate that is found right here. Let's put that in a box, put some stars next to that. All right, this is your slope formula. Rise over run equals delta y over delta x. All right, that little triangle there is the Greek letter delta. And the way that you calculate this means the change in y over the change in x. So I'm going to do y2 minus y1 over x2 minus x1, which means I need to have 2 points that the line passes through in order to calculate the slope. Let's show how we would do that in our first example underneath. Question number 3 says, state the slope of each line below. So here's my line on the graph, and what I'm going to do is identify 2 points that the line goes through. Okay, I can use any 2 points. I see right here, for example, that it goes through the point 0, -2. All right, that's the point 0, -2. And I can see that it also goes through this point right here, which is 2, -1. 2, -1. Okay, the way that I'm going to calculate my slope, remember, is finding the change in y over the change in x. Delta y over delta x equals y2 minus y1 over x2 minus x1. So when we calculate this, I have to determine which one of these points I want to be the first one and which I want to be the second one. It doesn't matter which one is which. Let's use 0, -2 as point number 1, and let's use 2, -1 as point number 2. Okay, the first thing that I need is the y coordinate from point 2, which here I see is -1. -1 minus the y coordinate from point 1. The y coordinate from point 1 is -2. So to find the change in y, I'm going to do -1 minus -2. And now I'll do the same thing for the x values. Okay, the x value of point 2 was 2, and the x value of point 1 was 0. So that's going to be an easy calculation. When I evaluate now, well, the denominator, 2 minus 0 is just 2. -1 minus -2, remember, is the same as -1 plus +2. -1 plus 2 is equal to 1. And there I see is my slope. The slope of this line is equal to 1/2. Okay, and that makes sense here because I can see that the line is increasing as I move from left to right, so my slope had to be positive. All right, let's practice calculating slope on our second graph. 2 points have already been plotted for us. Let's figure out their coordinates. This first one here is at 1, 2, 1, 2. And the second one is at 1, 2, 3, 1, 2, 3, 4 in the negative direction, 3, -4. All right, let's calculate the change in y over the change in x, which remember we're going to do y2 minus y1 over x2 minus x1. And let's make point number 1, 1, 2. Let's make point 2, 3, -4. The y value of point 2 was -4, minus the y value of point 1 was 2. The x value of point 2 was 3. The x value of point 1 was 1. And now we evaluate. -4 minus 2 is -6. 3 minus 1 is 2. And -6 over 2 is equal to -3. So the slope of this line is equal to -3. And again, that's a negative slope. As you move from left to right, the line is decreasing. All right, how about on our next graph here? Again, let's find 2 points that are on that line. I can see there's a point right there at 0, 1. And I can see there's another point here, which is at 1, 2, 3, negative 1, 2, 3, 4. Again, 3, negative 4. Let's calculate our slope. Y2 minus y1 over x2 minus x1. Let's make 0, 1 point number 1. 3, negative 4 is point number 2. The y value of point 2 was negative 4, minus the y value of point 1 is 1. The x value of point 2 is 3, minus the x value of point 1, which is 0. If we go ahead and calculate this now, negative 4 minus 1 is negative 5. Over 3 minus 0 is 3. And this fraction, negative 5/3, does not simplify. So the slope of this line is going to be negative 5/3. And again, I can see that I have a negative slope as I move from left to right. So that had to be a negative slope. Okay, so the slope is nice. Remember that the slope tells you the rise over the run. So the numerator represents the rise, what the change is vertically, and the run tells you the change horizontally. That'll be the denominator. So when the slope is 1/2, this means to get from one point to the next point, I have to go up 1 and then to the right 2, because these are positive numbers. Positive in the vertical direction is up, positive in the horizontal direction is to the right. So I go up 1 over 2, and there's my next point. Up 1 over 2, there's my next point. That's my slope of 1/2. A slope of negative 3 is the same as negative 3 over 1. So again, the rise is negative, which means we're actually going to be going down 3 and then to the right 1. So here's my point. If I go down 3, 1, 2, 3, to the right 1, that point is on the line. If I go down 3 to the right 1, again, that point is on the line. Same thing with the slope of negative 5/3. I would go down 5 to the right 3. 1, 2, 3, 4, 5 down to the right 3 gets me to the next point. Let's look at a couple of different lines that are going to have special slopes, okay? In this graph, the line here is going horizontally. Let's calculate the slope. Remember, we need to do y2 minus y1 over x2 minus x1. And let's go ahead and pick out some points that this line goes through, okay? So I can see here's the origin. If I just go down 1, that's 0, negative 1, okay? And let's just pick any other random point, like this point right here. That's 1, 2, 3, negative 1. 3, negative 1. Okay, let's make 0, negative 1, 0.1, 3, negative 1.2. The y-coordinate of 0.2 is negative 1, minus the y-coordinate of 0.1 is also negative 1. The x-coordinate of 0.2 is 3, minus the x-coordinate of 0.1 is 0. And if we go ahead and evaluate, negative 1 minus negative 1 is the same as negative 1 plus positive 1, which is 0. And 3 minus 0 is 3. 0 over 3, though, is equal to 0. So the slope of this line, this horizontal line, is going to be 0. All right. What about with this next line right here? Notice this is a horizontal line. Again, let's just find any 2 points that it goes through, like this point right here, that's at negative 3, 0. And let's pick that point right there. That seems like a good one. That's negative 3, positive 3. All right, y2 minus y1 over x2 minus x1. All right, let's make that one point number 1, that one point number 2. The y of point 2 is 0, minus the y of point 1 is 3, over the x of point 2 is negative 3, minus the x of point 1 is also negative 3. 0 minus 3 is negative 3. Negative 3 minus negative 3 is the same as negative 3 plus positive 3, which makes 0. Okay, well, what's negative 3 divided by 0? If we were to punch this into our calculator. All right, let's go ahead and do that. Negative 3 rather, is going to be divided by 0. And we get an error. Our calculator doesn't like that because, if you remember, it's impossible to divide by 0. All right, that means that this is what we call undefined because it's not possible to divide by 0. So the slope of this this vertical line right here, the slope, we're actually going to say is undefined. All right, so let's fill in the blanks that we have underneath. Notice that the last two graphs show a horizontal line and a vertical line instead of a diagonal. A horizontal line, like we saw right here, will always have a slope of 0 because there is no vertical change. Okay, remember that the numerator is the vertical rise, and we calculated here that that's equal to 0. And you can even tell by looking at the line, it's not going up at all. As we move from left to right, it doesn't increase or decrease. There is no vertical change. So the slope of every horizontal line will be 0. A vertical line will always have a slope that is undefined because there is no horizontal change. All right, looking at this line right here, it's just straight up and down. It doesn't move left or right at all. So if I move from left to right, well, I can't really say it's increasing, it's decreasing, it's not staying constant because it's just a solid vertical line here. That makes the slope undefined. Our next example asks, do the first three graphs in example 3 represent a proportional relationship? Explain your answer. Okay, so here was example 3 that we just did, and looking at these top 3 examples here, all right, notice that they all show straight lines, so that's good, but we also need them to pass through the origin. All right, here's the origin, but that line doesn't pass through it. Here's the origin, but that line doesn't pass through it. Here's the origin. It's close, but that line does not pass through it. So even though they're straight lines, they do not pass through the origin. So we would say no. These are non-proportional relationships because the lines do not pass through the origin. All right, it's not enough to be a straight line. It also has to pass through the origin. So those 3 graphs are non-proportional relationships. All right, well, many times lines will not pass through the origin, but lines of non-proportional relationships still have a slope. Because of this, the variable k will not represent slope, only the constant of proportionality. Slope will be represented by the variable m. Let's underline that. All right, the variable m is going to represent slope. Okay, so every time I refer to slope, I'm going to use the variable m to represent it. Like in example number 5. Line A and line B are graphed together. What is the slope of each line? Okay, so line A, m equals, the slope equals. Line B, m equals, the slope equals. Let's go ahead and calculate each of those slopes. We'll start with line A, which is right here. Okay, and they've got 3 points that are on line A. I only need 2 of them. And how nice is that, that the origin is one of them? So I can use 0, 0 as one of my points. And then this point right here is at 4, 3, 4, 3. All right, let's make the origin point number 1. 4, 3 can be point number 2. We're going to do y2 minus y1 over x2 minus x1. y2, that's going to have a value of 3 minus the origin, so that's going to be a 0. x2 was 4 minus, well, again, the origin, so that's going to be 0. This is going to be easy to calculate. 3 minus 0 is 3. 4 minus 0 is 4. So the slope of line A, m equals 3/4. How about for line B? Again, they gave us 3 different points here. Let's use that first one, which is at 0, 4. And this second one, which was at 4, comma, it looks like 7. 4, 7. Okay, here's the origin. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Yep. So again, we're going to do y2 minus y1 over x2 minus x1. Let's make 0, 4.1. 4, 7 is 0.2. That means y2 is 7 minus y1 is 4. And x2 is 4 minus y1, or x1 rather, is 0. And so if we calculate this, 7 minus 4 is 3. 4 minus 0 is 4. So the slope of line B, m equals 3/4 as well. And that's not a coincidence, okay? I would say that line A and B are parallel to each other. Parallel means that they will never intersect, all right? If they never intersect, that means that the rise over run has to be the same every single time, meaning that they have to have the same slope. If these lines didn't have the same slope, then at some point they would definitely intersect with each other. Line A shows a blank relationship. Well, here's line A. It's a nice straight line, and it's going through the origin, so I know that it is a proportional relationship. What is the equation of line A? All right, well, it's a proportional relationship, which means it has to be in the form of y equals k times x. And if we remember from earlier, k, the constant of proportionality on a proportional relationship, is the same as the slope. So the constant of proportionality for line A is 3/4, which means that the equation is y equals 3/4 x. Part C, what can you say about each point of line B compared to line A? Where does line B begin? Okay, so if I look at the first points, all right, I see line A and then right above it, line B. Second point, same thing, line A, above it, line B, line A, line B. This distance is the same distance. So if I were to count up, that's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Each point of line B, is 4 units above line A. Where does line B begin? Line B starts at, and then what are the coordinates? Well, line B starts right here that we said earlier was at 0, 4. All right, so we just said that line B begins at 0, 4. So what is the equation of line B? Well, if we remember what we said here before, the equation of line A is 3/4 x. And then every point of line B is 4 units above line A. So to get from line A to line B, I would have to add 4. So that means I'm going to have the same equation set up, y equals 3/4 x. Then I'm just going to have to add 4. So since line B starts at 0, 4, the equation of line B is y equals 3/4 x plus 4. This is known as the slope-intercept form of a line. And that's what we're going to discuss here in the box, the slope-intercept form of a line. A non-vertical line can be modeled using the equation y equals mx plus b, where m is the slope, which we've talked about in depth before, the change in y over the change in x, and b is the y-intercept, which is where the line crosses the y-axis. Okay, so if I look at line B again, I had calculated line B's slope already. Line B's slope, we said, was 3/4. Okay, and then I can see right here that it's crossing the y-axis at the point 0, 4. So the y-intercept, b, would have to be equal to 4. So y equals 3/4 x plus 4 is in the slope-intercept form, y equals mx plus b. M is your slope. B is the value where it crosses the y-axis. So let's practice that underneath. We've got a couple of pictures. It says to calculate the slope and identify the y-intercept for each line, and then write the equation of the line in slope-intercept form. So let's start with this picture here on the left. Okay, the first thing I'm going to look for is the y-intercept. What's that b value? Where is the line crossing the y-axis? Well, right here is the y-axis, and the line hits at that point right there, which is 1 unit below the origin, which is at 0, -1. Since it crosses the line at 0, -1, the y-intercept b value is going to equal -1. Now let's calculate the slope. Remember that slope m equals y2 minus y1 over x2 minus x1, change in y over change in x. And we need 2 points. Well, I've already got 1. Let's use the y-intercept. Let's use another point that's on the graph, like this point right here. That is at the point 4, 1. 4, 1. All right, we'll make the y-intercept point number 1. We'll make 4, 1 point number 2. That means our y2 value is 1 minus our y1 value, which is -1. And our x2 value is 4 minus our x1 value is 0. And now if we calculate this, 1 minus -1 is the same as 1 plus +1, which is 2. 4 minus 0 is 4. And 2/4 is the same as a half. So the slope m equals 1/2. Now I need the equation of the line in slope-intercept form. And again, the slope-intercept form is y equals mx plus b. So I'm just going to substitute the values of m and b into the equation. Y equals m, which is 1/2 x, plus b. But notice that b is -1, so we're just going to write -1. The equation of that line right here is 1/2 x minus 1. It's crossing the y-intercept at 0, -1. And to get from one point to the other, I'm going to go up 1 to the right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2, etc., etc. Let's try it again on our next graph. Calculate the y-intercept and the slope. The y-intercept is at this point right here, which I know is at 0, 5, meaning that the value of b is +5. For the slope, y2 minus y1 over x2 minus x1. Let's pick out our points. We've already got 1 for the y-intercept at 0, 5. How about this point right here at 1, 2, 1, 2. All right, the y-intercept can be 0.1, 1, 2 can be 0.2. y2 is 2 minus y1 is 5 over x2 is 1 minus x1 is 0. 2 minus 5 is -3 over 1 minus 0 is 1. -3 over 1 is the same as -3, so m, the slope, is -3. And now let's write the equation. Y equals mx plus b. Y equals -3x plus 5, because it was a positive 5 where we crossed the y-axis. So that is the equation of the second line in slope-intercept form.